was cool. The Cincinnati Red Star. Red Stars make carbon. C for Cincinnati, the Red Star. She even had a red part on her heart. So the evil forces that be. Today, vitamin D. We just saw a great lecture on this. So we're going to redo this poster here that we did a while back. And just to show how our technique has gotten better. We were trying to find what was significant about vitamin D. What happens is you get this in your body, the 7 cholesterol. What you got to do is get an ultraviolet B, which is a higher wavelength. It's higher energy. A is in between with visible. So to get the B, you're busting this ring open here. So as I was looking at this, I'm like, hey, our technique's supposed to make this easier, right? Well, I couldn't distinguish what was going on. 4 reactions. We're going to have 4 molecules here. So the first reaction is busting the cholesterol ring open. So you're going to have these double bonds. The old days, look, we had green because I was into the electron thing. That's a whole different theory. So when we're talking molecular here, double bonds get the yellow. Highlight them. It's just that simple. So the green was confusing us. And then I found we changed colors on the red for these diamonds. So we're going to redo this here. If you remember our serotonin, dopamine, dopa transgression across, epinephrine, adrenaline one, it was only hydroxylations. It got to the point where there was a triol. Well, look, 1, 2, 3. The ultimate part of vitamin D that you want, they're calling it a 125 dihydroxy. It's actually a tri, but they're just counting the 2 new ones that make it different. So this is happening in the liver, does one of the OHs, and it goes through your kidneys. In the cell outside, your endoplasmic reticulum starts hydroxylating. That's where these hydroxylases are. You need an NADPH to do these and stuff. So we're going to go through again and start with the 7-dehydrocholesterol. So really what it is, it's an ene. Look. See why I was saying now with the yellow, it's easy to look at a molecule and see where the important part is. You got a green OH, you got a double bond. Everything else is just hydrocarbon, hydrocarbon, hydrocarbon. This is one of the first ones we did. Watch how far we've come. So now when we look, you busted that ring open. Now you got 3 double bonds. I wonder if that first was aromatic. I'm going to go back and look through some of that. And then what you get is this thing becomes a sliver now. Notice how it's a long, straight molecule. And look, you get an OH on one end, all the way through OH on the other. And this is where the highlighting comes in. Look, you got a methyl dihydrogen one there. Double bond there. Double bond there. So what you see is this is conjugated. Boing, 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 boing. So all through the middle here, it's got a pi bond running up, keeping that thing. Oh, this is cool chemistry, okay? Simple hydrocarbon rings. Okay, so when we go through and we color code them, you're going to see how simple that really is. And now again, look, I was even looking at this, trying to find out what was the big deal? What was the whole thing about vitamin D to begin with? What it is getting these double bonds in here for stability and hydroxylating it. So now it's recognizable. It's got a little bit of energy. You can start boinging it and releasing water and causing reactions. That's what happens when the chemicals in your body are used. So this is what you want to end up with, the 125 dehydro. So we're going to try it again. DCL capo, as they say in the symphony. Means we're going to take it again from the top. Start with our old recycled markers. This is all recyclable materials, kids. out of the church dumpster. So we kind of got to draw this one sideways anyway, so we're going to maybe angle it a little bit here. It's not going to work. It's going to show the stuff underneath. We're going for a 7-dehydrocholesterol. 7. Can we read this here? We're talking about the number 7 dehydro. That's just comparing it to the other one, so that doesn't even really count. No pencils for this. Let's see here. We got a ring. Just a simple ring. I want to save space here. I don't want to draw this too much. Let me say here. So it gets methyl. Broke my favorite black crayon. Great. Well, that was holding that up there nice too. So. This is going to be a methyl. We're going to take our time here, whatever it takes to feel comfortable. This starts off as a methyl. Just a 6-membered ring, so just draw it, worry about the bonds later. These we got pretty good at just drawing doubles, remember? We can connect that one. I think we're going to end up drawing this on the back because there's not going to be enough room here. So there's the first ring. We're going to draw this real big, I guess. So the whole idea is for this molecule to be so distinctive since it's so big. End up with an OH. Connect. Trying to keep them on the side here. It doesn't even matter. Yeah. These are just hydrocarbons, kids. CH2s. Trying to keep these side to side. Now we're going to go this way. Because what we want is to spread the hydrogens out to give it more of a three-dimensional flare. So when we're showing this ring, we want the CH2s on opposite sides. Now this comes back down. That's just a CH2 too. See, we're so good at this now, we're expecting something complicated. It's just simple hydrocarbon chemistry. Look at that ring. This is our starting one. So what it gets here is a double bond to the next ring. Color that in right away so we know where we are. I think our used markers are getting worn out here. So that takes care of that carbon. Coming up here is just another ring. Let's go. That way. There's going to be more ring coming up here. So let's back up a second. Color this in so that we feel comfortable. This is good beginner chemistry coloring for kids. Coloring, period.